Alright, so today we're going to be going over an 820-3115 board. It has no green light in the charger, and also PP-Bus G3 Hot is completely missing and absent. So let's go over some of the things that we should go over when there's no green light in the charger. So, in order for there to be a green light in the charger, let's just open up a schematic here and get to where we explain everything. Wrong. Maybe? Yeah, this is good enough. All right, so let's go over to what's going to give us a green light. So what has to happen for this to occur? I'm going to go through this step by step. The first thing that has to happen is that the 16 to 18 volts has to come in from the charger over here. After that, wow, even in, seriously? You're still at 3 frames per second? Oh, let's do this instead. How about this? This? Huh? Huh? Nah. Oh well. That's a little better. So first we have the 16 to 18 volts coming in from the charger. Now, that's going to lead down to a voltage divider. If you don't know what a voltage divider is, watch my other videos on what a voltage divider is. I've covered this. It's going to turn the 16 volts into 4 volts for the charger AC in pin. The charger AC in pin will then get its 3.9 to 4 volts. Once it has that voltage, then charger ACOK is going to come out of pin 14 over here. Now, charger ACOK is going to come out assuming that the current sense resistors are not telling the chip, oh my god, it's using too much current, turn off the charger. So if we go over to where charger ACOK shows up, you'll see that charger ACOK on the top of the schematic winds up turning into SMC BC ACOK. So we go up to the top of the schematic and we see that there's a little logic gate. If you don't know what a logic gate is, you can watch some of my other videos where I talk about what a logic gate is. Now, the way this logic gate works is if there is voltage present on the input pins A and B, then whatever's on pin 5, which is 3.4 volts, will be passed through pin 4. So if SMC BCACOK is present, then 3.4 volts from PP3V42 is going to be passed on to this IC. Now the VCC pin is a pin that... Stop hitting each other! You clearly hit him! Well, he's clearly smart enough to hit you when I'm not looking, so I can only assume that you hit him first. Employees, man. Anyway. So, this over here is on the VCC pin. There's going to be 3.4 volts. Now, the VCC pin is kind of like a VIN pin. What a VIN or a VCC pin is pretty much power to turn it on. So, for example, this is my microscope camera. I have this cheap little, crappy little wall wart power supply, and I'm plugging it into the VCC or the VIN pin. That's pretty much power to turn it on. Now, once you have power on that, what's going to happen is this chip over here is going to allow the external, the charger, which is the adapter sense line. This is the charge port over here, by the way, J6900. It's going to allow the adapter sense line, meaning sensing the adapter, to talk to the sys1 wire line, which is on the SMC. And this over here is the SMC. So this is going to give me a green light in the charger. So let's go through here and go through step by step and see if everything is going the way it's supposed to, shall we? In logical order. So, first things first, on D7005 on pin 1 and 2, I should see 16 volts. So let's find D7005 on my board view software. So I'm going to look for I'm going to switch the screen, even though you're going to wind up seeing it at the whole 2 frames a second shit. I need it for my own convenience. So I'm going to switch over here, get display capture, and yeah, sorry. I need to be able to see this shit both at a time. And I don't want to fuck with Open Broadcaster anymore and create new scenes every time I need to do this. So we're going to look for D7005. And that's down here. Right? Now, let's turn on the microscope camera. 16 volts, right? Okay, now we're going to check at the voltage divider. Let's see if pin 3 has charger ACN. It's always upside down. Remember, it's always going to be different on the screen than it is on the fucking motherboard. That's the way the software is programmed. Am I on the right resistor? Yeah, I'm on one of the right resistors. So we got 4 volts. So 4 volts going to DCN, good. Now let's see if we have charger AC OK coming out. Charger AC OK is going to be on pin 14, which is this one. So 0.4. Now, I'm going to unplug the charger from the motherboard, and now I'm going to check the resistance of the entire current sensing circuit. So we're going to see if this, and if you don't know what current sensing is, you could watch many of my other videos on what current sensing is. Remember, I've been doing this channel, I've been doing this content for 2 or 3 years now. I really can't go over every single thing every single time. So I'm just going to tell you to view other videos that I've done where I explain how this works. By the way, a lot of people asked in my other video, why don't I check on the probe pads? Why am I checking on the legs of the chip, which is a pain in the ass, when I can check the total resistance in the pads? The reason for that is that very often there can actually be some kind of burn that you can't even see, so the laminate is still intact, but under it the copper is broken from a spike of voltage. And when I measure on the pads, I'll see infinite resistance. When I measure on the pins of the chip, I'll see infinite resistance, but when I measure over here, it'll be just fine. See, if I measure over here, I'm totally leaving out from here to here and from here to here. I'm not testing that at all, and I want to test all of that, which is precisely why I always measure at the legs of the chip. I cannot tell you how many students I've had come here that got owned because they were measuring at the pads instead of at the pins of the chip. And every time they do that, they would get some easy measurement on the pads, but they wouldn't notice that this to that was actually broken. So yes, trust me, there is a reason for everything I do. Here's the thing. I don't mind. I know that I'm wrong every now and then, and I'm always open to people giving their opinions or giving advice. But when I'm doing something very specific like that, and I get 20 comments saying, "Lewis, you're doing it wrong. You're measuring this." Can you give me a little bit of benefit of the doubt that maybe there's an actual reason I'm doing it that way? Maybe I'm doing it that way because over the past 6,000 or 7,000 of these that I've done, I've realized that there was a point to it. Because there is a point here. Just I want you to think about this. Instead of saying, Lewis, you're doing it wrong, you could say, you could be measuring on the probe points. I see that you could probably measure on the probe points and it would be a lot easier for you. Have you considered doing that? And then I could say, well, I have considered doing that, but the reason I don't do it is because it doesn't test the trace between the probe point and the IC. You never know. You may learn something. Because, again, I don't know everything. I'm always open to the fact that I may be able to learn something from somebody else. Maybe you should be, too. Anyway, so beyond from that, and trust me, I'm not talking about any one specific person because I would say between comments and messages, because I get a lot more messages than I do comments on stuff like that, there's at least 20 or 30 of them. So I'm not calling out any one person specifically. Now, the current sensing is fine. Now, if you look closer on this chip, you're going to get a little bit of a hint that it's fucked up. See where it's supposed to say ISL 6259 AHRTZ F244 and the 44 is kind of exploded? That means the chip itself is probably fucked. So I'm going to turn the air filter on as high as it goes, remove the chip, replace it, and see if after this is done, we get something. Come on, turn on. Turn on, little JBC. I drop this thing off the desk all the time. I love the JBC station, but this whole counterweight thing is such a fucking piece of shit. Watch this. Let me just turn it off so I don't kill myself. Okay, it's not going to do it on camera. But look, it's so easy to knock this thing over. Every time I get up, I have this under the desk, but it's not spooled or anything. So every time I get up to go to the bathroom, I wind up knocking into this thing. It drives me fucking crazy. I'm walking along, and it moves this way. It swings back, and then when it swings back, it just knocks itself off the desk. And that's the thing. My HAKKO FR801, I am less able to knock that out of the little fucking bent paper clip that's holding it in than this. The HAKKO was $600 when I bought it. This shit is $1,800. What the fuck? Anyway, rant over on that because even though it's $1,800, I did get it for free. So I can't really bitch. But I can. But I shouldn't. But I do. But I shouldn't. Story of my life. Now. Goodbye, little ISL chip. Let's just put some flux to remove it a little easier. I usually like making my life hard, but in this instance I'll make it a little easier. Okay. Remember, you always have to use more flux than is necessary, or else you're not going to annoy the engineers. It's imperative to annoy the engineers. That's almost become part of what I enjoy about doing these videos at this point. Just knowing that an engineer troll is watching this, cursing, screaming, going, "That's not the way you do it." I don't know what it is, but I get a kick out of it. This is one of those areas where if you're one of those people who thinks that the Aten 858 is the same as an $1,800 JBC, this is where you'll notice a difference. Because this part of the board has very high thermal mass and it takes a lot of heat to get anything done. It's very difficult for novices to solder around this part. Even people that have been doing well on other stuff, I notice a lot of people screw up here. Particularly because it's just really difficult. This is a multi-layer PCB, and this area is meant to deal with a lot of power. And that middle pad is kind of more of a heatsink than anything else, more than a grounding pad. So, if you have a preheater, it takes away some of the... It definitely takes away some of the challenge if you have a preheater. But if I remember not having a preheater, the first time I tried that Aten thing and I tried removing this chip, I'm not kidding, I was sitting there for 6 minutes. Jessa and I just threw the thing in the fucking trash. Like, at max temperature, 6 minutes in, the chip was still not off the board. Just a joke. And I'm not against cheap shit, trust me. I use a fucking titanium rod and a screwdriver to fix, not fix, I guess to straighten out iPhones. Well, I used to when I actually did screen repairs. I don't anymore, but you get the point. I use alcohol instead of a FLIR cam to detect shorts because I feel that the FLIR cam is going to take me the exact same amount of time except cost me a bunch more money in most cases. I'm open to spending money when it makes sense, but I don't spend money when it doesn't make sense. I'm cheap. Trust me, I'm very cheap. But when it comes to shit like that, the reason I don't use those cheap stations is I can't get anything done. I've tried. And it really gets into perspective when you do something like, let's say, try to solder a chip to let's say you're soldering a SPI ROM chip to the little BIOS programmer board that I have. That thing has no thermal mass. It's a single layer. If I use the same temperature that I'm using right now to get this off, I'm not kidding, you'll see that the solder stays molten for over 25 seconds. Like, you can count 25 seconds it stays molten because it's just too hot. We sell these chips, by the way, on the mailin.repair website. So if you want ISL 6259 chips, you can buy them there. I have tons of spools available. Discounts if you buy more. But yeah, of course the Aten is going to be fine for that stuff, like single layer, but when I actually try to do work on here, I try it. I want that thing to work. I'm a cheapskate. I'm a big cheapskate. I like when cheap shit does the job. I don't like spending money for no reason. But I would just be torturing myself using that stuff. I'll try a different method than I usually use. Usually I solder this chip on by just shoving it in there and then cleaning up everything afterwards. Which I'm probably going to do this time too. Tap it in. Bam. Now I want to get it nice and flat on the board. Push down. It being flat on the board is the most important thing. See, you think it's soldered. You think it is. Then you do this, and you see that you got all these voids. Let's make this look factory, shall we? Like factory. The T30-KN tip from HAKKO on the HAKKO FM 2032 iron. AKA idiot proof. Shit, if I can solder with this thing, anybody can. HAKKO's not paying me to say that either. HAKKO's too smart a company to have people like me endorsing them. I can... Fucking air filter. Okay. All the excess just gets tossed onto the iron. So, not really a such thing as too much here because I'm making sure that all the excess goes to the iron. Not trying to get excess stuck on the board. Okay. Now let's see if we have any change in activity. Let's turn off the wind turbine here. Always good to stay hydrated throughout your day. Hey, you're supposed to be sleeping. Sleep. Any change? Yay. Look, the fan spins and the light is green. Could I ask for anything more? So that's that for today. And as always, I hope you learned something.